Hey everyone, welcome back to Proactive Prudence. In last class, we studied about the anesthesia technology and a chapter called Anesthesia Machine. We covered cylinders, pin index system, yoke assembly, and various other parts of anesthesia machine. So, in this video, we'll be studying about the central supply of oxygen and nitrous oxide, the continuation of anesthesia machine chapter. Okay. So, central supply of oxygen and nitrogen in large hospitals where consumption of gases is more, oxygen, nitrous oxide, and air are supplied through central supply pipelines. In central supply rooms, oxygen and nitrous are stored in a set of 4 to 8 large cylinders connected to a common manifold. Many hospitals use a liquid oxygen tank instead of cylinders. So, in large hospitals, there are more patients, and the requirement of oxygen, nitrous oxide, and air is very much high. And so, in that cases, there are central supply pipelines that are being that are supplying oxygen, nitrous oxide, and air to the anesthesia machines. So these central supply rooms have a big cylinders which are type H, which is the very big cylinders wherein oxygen and nitrous oxides are stored, and they are connected to each other into a common manifold. And many hospitals use liquid oxygen tanks instead of the cylinders that are being used. So in India, oxygen, air, and nitrous oxide are supplied at a pressure of 60 psi, pounds per square inch. So that is the pressure of the gas that is being supplied through central supply. So in OTs, you can observe that there are certain pipelines which are connected to a big box thing that is connected to a wall, the ceiling. So that is the central supply. From the ceiling of the this thing, the oxygen, medical air, and nitrous oxide are being used to the supplied to the machine, anesthesia machine. So each a gas is being given a color code. So the central supply pipelines with color coding: white for oxygen, okay, blue for nitrous oxide, and black for air. So those are the different color codings for the different oxygens that are being obtained from the central supply. So the majority of hospitals have central suction also. So this suction pipes are yellow colored. That is a central supply of oxygen and nitrous oxide. So each of these, similarly, we saw that pin index system in the last video, wherein pin index is used to prevent wrong fitting of the cylinders. These central supply also have a certain safety measure, which is a diameter index safety system, DIS, which prevents wrong fitting of the central supply pipelines to the machine. As the name suggests, the diameter of oxygen, nitrous oxide, and air and suction pipes are different, so that they couple to the oxygen, nitrous oxide, air, and suction only, so that they receive the same gases in these pipes. So, oxygen flush or the emergency oxygen flush, it is a bypass system which bypasses the intermediate and low pressure system. It bypasses the intermediate and the low pressure system. So firstly, we saw the three different systems that are that is observed, pressure systems that are observed in the anesthesia machine: the high pressure, the intermediate pressure system, and the low pressure system. So we saw the high pressure system, there are cylinders and central supply, and this oxygen flush is also a part of high pressure system also. It directly bypasses, that is, it is directly given a connected to the common gas outlet. So it bypasses in the sense it doesn't go through intermediate and low pressure system, it directly reaches the patient. So oxygen is directly reaches to the machine outlet. It delivers 35 liters of oxygen per minute at a pressure of 45 to 60 psi. So that is the pressure of the oxygen flush. That is, there's a button in the anesthesia machine called oxygen flush, wherein on pressing the button, there is a flow of oxygen with a pressure of 45 to 60 psi, and the 35 liters of oxygen per minute is being delivered. So that is the oxygen flush. Moving to the next one, high pressure regulator. So this high pressure regulator is the first stage pressure reducing valve. So you can't directly give around 60 psi to the patient. The pressure of the gases cannot be directly given to the patient, so it has to be reduced. So these reducing work is given to the high pressure regulators. So there are two different stages of pressure reducing valves. So the first stage is wherein after crossing the cylinder cylinder okay, after crossing the first stage of the pressure, so that is reduced by these pressure regulators. So it converts high pressure in the cylinder to a constant working pressure suitable for the anesthesia machine, and it reduces the pressure to 45 to 60 psi. So that is the pressure regulator. Moving to the intermediate pressure system, which is the second stage of pressure reducing valve, to the flow control knobs. So in the anesthesia machine, the intermediate pressure system is extended from second stage pressure reducing valve to the flow control knobs. It includes second stage pressure reducing valve, which can reduce the pressure to 15 to 35 psi. So firstly, the high pressure regulator used to reduce the pressure to 45 to 60 psi, but in the second stage pressure reducing valve, it reduces to 15 to 35 psi. There is oxygen failure alarms also. Whenever the machine starts alarming, it is considered that the pressure of the oxygen has fallen down. So that the alarm system in the machine can indicate various faults or the pressure reduction or any default in the oxygen failure. The alarm system starts ringing. Then there is fail-safe valve. This is an important safety device which, in case of decreased oxygen pressure, either cut off or proportionately decrease the flow of nitrous oxide and other gases. So whenever there is a decreased oxygen pressure, there is either cut off or proportionally decrease in the flow of nitrous oxide and other gases. So that is called as fail-safe valve. Thus it prevents the delivery of hypoxic mixture. Hypoxic is low oxygen content of mixture of air to the patient. So that is a fail-safe valve. Moving to the low pressure system, the last pressure system, which will directly move into the patient's common gas outlet. So downstream to flow control knob constitutes a flow pressure system. Below the flow control knobs are the pressure system. So it includes rotometer, vaporizer, and check valve. So these can be observed in the front of the machine on the below the monitors. So these rotometers are one of the most important component of low pressure system. These rotometers contains flow meter tubes specific for each class and flow control knobs. The flow to each tube is adjusted by rotating the flow control knob. So by rotating the knobs, you can control the flow of the gases. So it could be clockwise or anti-clockwise. And the safety measure of this flow control knobs are, they have certain color codes. They have color codes. They also have chemical formula of gas embedded on the each knob. So the chemical formula of the gas that is being controlled by flow control knob is being expressed on the knobs. And then we have oxygen knob, which is made physically different from other knobs. That is, this oxygen knob is more fluted, it is more prominent, and has a very large diameter. So the oxygen knob is made physically different from other knobs. So the three knobs that are going to be present are nitrous oxide, oxygen, and air. So nitrous oxide has a blue colored knob, oxygen has a white colored, and a black color for the air. So these are the different color codes for the flow control knobs. Going to the flow meter tubes, that is the next thing about rotometer. Flow meter tubes are the glass tubes which are transparent and have a variable orifice. So they have a tapered, narrow at base and wider at the apex with markings on each tube indicating the flow. These tubes are also called as Thrope's tubes. Although the tubes are transparent, but still it is not possible to see the gas flowing through it. To ensure continuous flow of gas, each tube contains an aluminium. Okay, each tube contains aluminium float called bobbin. The gas stream passing all around the bobbin keeps it rotating continuously and ensuring continuous flow of gas. Upper end of the bobbin determines the flow rate. Okay. The flow at low rates is laminar, and therefore viscosity determines the flow, while the density becomes an important determinant at high flow rates. The whole unit with the flow meter tubes and the flow control knob is called as rotometer. Okay. So the diagram here is a flow meter. You can see the flow control knob. So this is used to control the flow of gases. Okay, let me show it with the diagram. Okay, this is the flow control knob, and this flow control knob is used to control the flow of gases. This is a Thrope's tube wherein the gas flows from the cylinder passing through the first stage reducing valve and the second stage pressure reducing valve, and then moves into the flow meters. So when the gas moves in, it encounters a bobbin which is made of aluminum, and whenever the gas flows, and if the flow control knob is rotated anti-clockwise or clockwise, the bobbin starts to rotate and move up and down, showing the flow of gas, the rate of flow of gas. So that is the function of the rotating bobbin. All together is called as rotometer. The flow meters, the flow control knobs, flow meter tubes. So that makes up the rotometer. So what is the safety features of a rotometer? The position of flow meters is in such a way that there is no leakage at any point. There should be no leakage, and the function of the flow meter tubes and common manifold at the top of the machine. If the oxygen tube is placed in upstream, it can show a leak in 6 positions. It can leak at 6 positions. While if it is placed at downstream, the leakage happens to be in only 2 points. So oxygen tube is always kept to the downstream. That is, the oxygen should be the last gas to enter the rotometer. So you can see here, these are the different flow control knobs that you can observe here. There is blue, there is air, and there is oxygen also. So that is the flow control knobs. So they have put the chemical formula also here. That is the for now, the safety feature of rotometer, and this you can see here an image that is being placed. So if oxygen is placed to the upstream, it is incorrectly placed, and the oxygen which flows through the flow meters and passes to the next position to the vaporizers, the oxygen might leak in 6 positions, that is 2, 3, 4, 5, and 6. So you can see that there is a leakage of the gas. If it is placed in the downstream, that is, if O2 is correctly placed in downstream, then there is only leakage in 2 positions, that is 5 and 6. And hence, oxygen is always said to be placed in the downstream position so that there is no leakage. So here also you can observe that there is nitrous oxide here, and the air and oxygen to be placed in the downstream. Then the next safety feature is oxygen nitrous or ratio controller or oxygen nitrous proportionating system. So these oxygen and nitrous oxide knobs are interconnected to each other. They work in the pulley manner. So whenever the nitrous oxide is rotated, the oxygen flow also starts to flow, automatically starts to be delivered to the patient along with the nitrous oxide. So that is how the safety feature is being adapted. Whenever there is a rotation of nitrous oxide or a increase of nitrous oxide, the oxygen knobs also show the automatic movement of oxygen flow. So that is the oxygen nitrous ratio controller. Moving to the next one, which is a fluorescent back panel of rotometer, so that it can be visualized in the dark also. The rotometers, in case of any laparoscopic surgeries, you can observe that the lights are being offed in order to observe the monitor correctly and do the laparoscopic surgeries. In that cases, rotometers are usually given a fluorescent back panel so that you can see the flow meters properly in dark also. Rotometers are hand calibrated to minimize the errors. They are anti-static to prevent sticking of the bobbin to the flow meters. So the throps tube that we observed, those are usually anti-static. That is, they do not cause any static static function. Moving to the other types of flow meters, there is head brink flow meter, which was used in past, and it had a metal tapered tube with inverted black float. Connell's flow meter, again it was used in back in past, and it had a round float bobbin. The reading was usually taken from center. Okay, now moving to the last topic of the low pressure system is vaporizers. So vaporizers are the devices which are used to deliver inhalation agents. Inhalational anesthetic gases are being delivered using these devices. You can see a vaporizer being put here. There is desflurin and sevoflurin vaporizers. Uh, the inhalation gases are usually in the liquid form. So these liquid form of inhalation agent should be converted into gaseous form, and that work is handled by the vaporizers. The inhalation agents are usually volatile fresh gas passing over the agent vaporizes them, and their vapors get incorporated into the fresh gas to be delivered to the patient. So firstly, the oxygen, nitrous oxide and the air together move into the machine. They cross the second pressure reducing valve. They move to the flow meters. From the flow meters it moves to the vaporizers. So in vaporizers, what do? They get mixed up with these vaporizing agents, which are inhalational agents. Together they are along with oxygen, nitrous oxide, air and anesthetic agents are delivered to the common gas outlet wherein it goes to the patient. So that is how the vaporizers work. So these vaporizers are usually made up of such a material that they have high specific heat and high thermal conductivity. That is, they have under certain temperature only the gases get converted into the liquids get converted into the gaseous form. So in order to maintain a high specific heat and high thermal conductivity, the material that is being used in vaporizers also determine the factor. So usually the copper is used because it has certain the properties of a specific heat and high thermal conductivity. And in few years, the modern years, there are certain developments that are made in the vaporizers. So in olden days, they were using ether bottle or trilene bottle or the Goldman vaporizer, which is being replaced by newer vaporizers such as Tech 5 and Tech 6. That is the heated and pressurized vaporizers that are specifically designed for the desflurin. Okay, then there is another type of vaporizer which is Aladdin cassette vaporizer. It is a very latest vaporizer which can deliver all the inhalational agents, and it is used. It is required for insertion of color coded cassette of each agent. So there is a color coding for each agent. So this Aladdin cassette vaporizer can be easily inserted into the anesthesia machine and can be removed when not in use. So these vaporizer can be easily put in and removed out. So the characteristics of the new vaporizers that are being used nowadays are that they are temperature compensated. That is, the vaporizer output does not affect any changes in the temperature, which occurs due to vaporization of the inhalational agent. So these vaporizers are not affected by the change in the temperature that occurs due to the vaporization of the inhalation agent. And there is variable bypass, that is by rotating the dial knobs that is being present. So these are the dial knobs, you can observe that. So the rotating these knobs can determine the flow of the, or decide the flow of the, how much fresh gas is needed to the pass through the vaporizer. So that is the dial knob. So the variable bypass can be one of the characteristics of new vaporizers. Then usually, that is, at 5% concentration, most of the gases will pass through the vaporizer, and 0.1% most of the gases will be bypassed. So that the controlling of this dial knob can determine the flow of the fresh gas that is being passing through the vaporizer. That is what is meant by variable bypass. Moving to the next characteristics, that is flow over, that is gas flow passes over the agent. Other type is bubble through, in which the gases passes through the agent. Flow over is the gases flows over, passes over the agent, and in few others the gases bubble through the agent. That is, flow over is, so if this is the inhalation agent, and the fresh gas is coming from here. Flow over is just touching the anesthetic gases and going. But in few other types, the fresh gases moves into the inhalation agent, causes bubbles and sprout up and causes a mixture of fresh gas, and is delivered to the patient. So that is flow over and bubble through. Next, not affected by pumping effect. So there is no back pressure that is happening in new vaporizers. That is one of the characteristic of the new vaporizers. Outside the circuit, that is not in breathing circuit. Agent specific. These new vaporizers are used in such a way that you can easily remove them. That is, they can be used interchangeably. You can remove it from the machine and put the other inhalation gas that you need for the time being. So there is no mixing of the anesthetic gases during the exchange of the different inhalation agent. So it is called agent specific. But they have given an example: halogen and isoflurane with almost identical vapor pressure can be used interchangeably with accurate delivery. Then the sequence of vaporizers. One machine contains more than one vaporizer at a time. The agent with lower boiling point should be placed first. That is near to rotometer, otherwise condensed particle will be recovered from the second vaporizer. So always the vaporizers should be placed in such a way that the agent with lower boiling point must be placed in the first place, so that the rotameters, oxygen, nitrous oxide, and air mixture does not move to the second one and then cause mixture of the anesthetic gases in the vaporizer itself. The required vaporizer should be put in the first place. Okay. Moving to the safety feature of vaporizer, the new vaporizers are agent specific. As I told in the characteristics, they are agent specific. They have special key filling system specific for each agent. So you can see in the OTs that while filling the anesthetic gases, they have a key for filling it. So whenever you put in, you put the bottle of anesthetic agent to the key system. It starts to get filled only if it is properly placed into the lock system. So that is how the agent specific safety feature is being adopted. Then there are color code markings mentioned on the vaporizers. The dial knob and the filling system are also of the same color. So the color codes are red for halothane. Okay, red for halothane. I'm putting pink instead of purple over there. Purple for isofluorine. Then yellow for sevofluorine. And blue for desfluorine. So these are the different color codings that are being given for the anesthetic inhalational agents. Then the interlock devices which prevent more than one vaporizer to be turned on at the same time. So these interlocking system has been so much useful that it prevents the other vaporizer or the two different vaporizers getting going into the patient at the same time. So that is being checked. The one way check valve, it is placed just before the machine outlet to prevent backflow effect of the positive pressure ventilation. In order to prevent the backflow effect, the machine has a one way check valve also being placed near the vaporizer. So various other parts of anesthesia machine that can also be observed are anesthesia ventilators. The ventilator in new anesthesia workstations have almost the same feature as in ICU ventilators. That is, they can work in volume as well as pressure mode. They can work in volume as well as pressure modes. So the majority of newer machine prefer ascending billows over descending billows because leaks are better detected in ascending billows. They will not ascend if there is leak, while descending billows will continue to descend in the presence of leakage. So the ventilators that are being adopted in anesthesia machine are of ascending billows because this ascending billows can detect the leaks very faster. So that is one major advantage of having ascending billow. Then the gas flow is compensation and fresh gas decoupling are very important safety feature in ventilators, which is being used in new machines. They provide compensation of leakage in fresh gas flow to maintain stable delivery of preset tidal volume. So that is an important point. So these ventilators provide compensation to the leakage in fresh gas flow to maintain the stable delivery of preset tidal volume, so that it monitors the tidal volume that is being preset. Then the scavenging system. So this scavenging system is being adopted to eliminate the exhaled gas from the patient to minimize the theater pollution. So the maximum permissible concentration of nitrous oxide in theater is usually 25 parts per million ppm, and that of the halogenated agent should be less than 22 pm. So the work environment or the operation theaters must maintain a scavenging system in order to avoid the pollution from the nitrous oxide or halogenated agents. So these are the different gases that are being produced during the patient is being under anesthesia. Moving to the mechanics of gas flow in anesthesia machine. So this is not so much needed, but we'll just go through how the yeah, this is important. Mechanics of gas flow in anesthesia machine. So this determines the flow of gas from where to where it goes. So firstly, the gases in cylinders are at high pressure. The high pressure regulator reduces the pressure to the 450 to 60 psi. Then again the pressure is being reduced to 15 to 35 psi by secondary pressure regulator, and the gases from second stage pressure regulator reaches the flow meters, wherein the flow is regulated by rotating the flow control knobs. So these gases mix in the common manifold at the top of the flow meter. gases mixed in the common manifold at the top of the flow meters, from where they are passed through the vaporizer and containing inhalation agent. The vapors of inhalational agents get mixed in the gaseous mixture with a final delivered which is finally delivered at machine outlet at a pressure of 5 to 8 psi. The final gaseous mixture delivered from machine outlet is called as fresh gas flow. So the final gaseous thing that is being a gaseous mixture that is being delivered from patient machine outlet is called as fresh gas flow. So the traditionally this gas flow consists of, let me highlight with another color. Okay. So the gas flow that moves to the patient consists of 66 to 66.6% nitrous oxide, 33.3% oxygen, and inhalational agent. So that covers the fresh gas flow. I'll just repeat mechanics of gas flow once again. So the gases move from cylinders or the central supply at a very high pressure. This high pressure is being reduced to 45 to 60 psi. From 40 to 60, 45 to 60 psi, it is again being reduced to 15 to 35 psi. After the 15 to 35 psi, it is being reduced. It moves to the flow meters. In the flow meters, the rate of flow of the gases are being controlled by flow control knobs. From the flow control knobs, the gases are being mixed in such a way that they can move to the vaporizers, and this mixing of gases takes place under one common manifold, which is above the flow meters. And after the gases are being mixed, they are passed into the vaporizer so that they get mixed up with the inhalation agents as well. After getting mixed with the inhalational agents, they are delivered to the final point, wherein machine outlet, wherein the pressure of the gas is 5 to 8. So from 45 to 60, it is being reduced to 5 to 8 psi. So that is how the pressure is being reduced in such a way that it can be delivered to the patient at a very low pressures, and that the final gaseous mixture that is being delivered to the patient in the form of fresh gas flow consists of 66% of nitrous oxide, 33.3% of oxygen, and inhalation agent. So that covers the very first topic of anesthesia machine, and we are done with all the safety features, the mechanics of gas flow in anesthesia, the vaporizers, the flow meters, the cylinders, the yoke assembly, and the boils machine also. So these are the different topics that is being covered under anesthesia machine. I think this is more than sufficient for the exam in the second year BSc ATOT. That covers today's topics. I hope you like the video. Please do share, subscribe, and like the video.